Hello everyone, Hari Sen. Welcome you back to Sri Chaitanya YouTube channel. So today we are going to start with vectors, but before completing vectors, right, in this transition course, okay, so this is the so let me brief you what is happening in this session, okay. So this is a transition course, and in this transition course basically we are bridging a gap between 10th and 11th, okay. So these are all the concepts, right, which are very important so that your journey in physics in class 11 becomes very easy, okay. For 11th and 12th it becomes very easy. These concepts are very important. So and till now we have done around 12 videos in this transition course for physics, okay. Please check out the playlist, okay. You go to the live section and you will see there a transition course, okay, playlist, and this is for both JEE and NEET because the concepts are the same, okay. This is what you will require, and once you go to JEE or once you go to your class 11th physics, right, when you start studying your chapter 1, right, that time you'll understand the importance of this part, okay. Without this, that journey will be very difficult for you, okay. You will have to come here, okay. If you want to write a sentence in English language, right, or if you want to write some words, okay, what is the fundamental thing you should know is the ABCD, right. So same thing here, that here also you should be knowing these fundamental concepts if you want to study physics very nicely, okay. So without further ado, let's start, okay. So before moving on to vectors, right, I had a very small part left in integration, okay. Yesterday we were doing integration, and integration, so what was left in integration? So basically I need to tell you today that what are the two types of integration, that are the definite and the indefinite integration, and also the applications of integration, okay. So let's start. So definite and indefinite integration, right. So what is indefinite and definite? Okay, so indefinite means, okay, we integrate without limits, right. And what are limits? Okay, so first of all we integrate without limits, simple integration, okay. So let me tell you, whatever we were studying till now was our indefinite integration, okay. We were studying indefinite integration where, let's suppose for an example, right, if I have to integrate x square dx, correct. So what is the integration of x square dx? It will be x cube by 3 plus c, right. So this is my indefinite integration, okay. So without using the word indefinite, we were studying the indefinite integration. But now what about definite integration? Okay, so indefinite integration, right, what will be the difference? We will integrate with limits, okay. So we will integrate with limits, okay. So now the next question that should pop up in your mind is, what is limit, right? What are limits basically, okay. So limits are some boundary values, okay. What are limits? Limits are boundary values, right. So now what are boundary values basically, okay. So let's for an example, if I'm playing cricket, right, so what do you have? That in the ground you have some boundary, no. Here is the pitch which we have, right, and this is the boundary, okay, that if the ball crosses this directly, it is a 6, right, correct. So this is the boundary which we have. Similarly in integration, right, I will tell you that you have to integrate from this boundary to this boundary, or from this limit to this limit, okay. So let's do a question, okay. We'll do the same question example, okay. What is the question? That integrate f of x equals to x square from x equals to 0 to x equals to 3. Let's say if I tell you that I have to integrate from of this function from x equals to 0 to x equals to 3, right? So now I have two boundaries, okay? I have two boundaries in this case. So let's first understand the theory that whenever I have a function fx, right, and I want to integrate, what is this? This is an indefinite integral. What is this? This is an indefinite integral because I have not, right, specified my boundaries. But once I specify my boundaries, what are the two boundaries? There are two boundaries. This is known as lower limit. Okay, this is my lower limit, my lower boundary, and this is my upper limit. Okay, this is my upper limit, okay, or my upper boundary. So I am telling you that you have to integrate from this part to this. Okay, this is my starting value, this is my ending value. So if you look in this question, can I say this will be my lower limit and this will be my upper limit? Correct? I know what is fx, this is my function which is given to me, but now it is very simple that what is the boundary? This is the boundary. Correct? So now how do you use this? Okay, how do you solve this type of question? Let's understand. Okay, so we now know what boundaries are, what limits are, but how to use them in the question. So let's try to solve this question. So in this, let's say that I have to integrate, right? I have to integrate my function, and what is the function? I have to integrate the function x cube dx, right? Let's suppose if I want to integrate this function. Okay, first of all, let's write the boundaries. So what are the boundaries? X equals to 0 to x equals to 3. Okay, I have written my boundaries also. Now let's integrate this. So what is the integral for this? So integration of x cube is x power 4 by 4. Yes or no? Plus some constant c. Okay, first of all, what we should do? We should integrate this as normally like indefinite integral. Now the role of limits will come into play. So what were the limits? So you will write, okay, the limits were from x equals to 0 to x equals to 3. Okay, so now what should I do now? So first step, okay, what is the first step? Integrate normally as you do for an indefinite integral. Okay, I will integrate normally as I integrate for an indefinite integral. What is the second step? Substitute upper limit. I will substitute my upper limit in my function. Okay, well, in my function, no, in my answer. Okay, in my this integral. Okay, in my answer. Correct? Okay, so first step is I should substitute the x equals to 3 because this is my upper limit. Okay, and third step is, right, substitute lower limit in my answer. Okay, I will once substitute my upper limit, I will once substitute my lower limit, and finally find the difference. Okay, find the difference. Okay, so these are the steps which you have to follow, right? So let's try to solve them. Okay, so now what I have done, so I have this integral, no, x power 4. Okay, let's write it again here, that integral of x cube dx from x equals to 0 to x equals to 3 is equal to x power 4 by 4 plus some constant c, and I'll integrate. What are the limits? The limits are x equals to 0 to x equals to 3. So first step is what I'll do, I will substitute my upper limit. So what do I get? 3 power 4 upon 4, correct, plus c, right? This is my upper limit, right? I will substitute my lower limit, right? Next step is substitute your lower limit. So 0 power 4, right? I will substitute x equals to 0. X equals to 0 upon 4 plus some c. And last step was find the difference of them. Find the difference of them. So what do I get here? Right? This will become 3 power 4. So 3 3s are 9, 3 9s are 27, and this will become 81. So 81 divided by 4 plus c, right? This will become minus. Now this is 0 plus c. So 0 will, and this will become minus c. So the c cancels with this c, and what do I get? Finally, I will get my answer as 81 by 4. Okay, so this is my final answer. Clear? So what is the step, extra step you have to do? You have to integrate and substitute the limits in my answer. Okay, and then take the difference of both of them, and you will get your final answer. So this is the extra step you have to do in definite integral. Okay, so with this we will move on to the application of integration. So what is the application of integration? Okay, so first of all, let's understand what is basically integration means. Okay, what if when you are doing the integration, basically what are you doing, right? So let's understand. So let's say I have a function, right? If I have a function y equals to f of x, right? And what is x? X is my input, right? And what is f of x? F of x is basically my y, right? And what is y? Y is my output, correct? So for some value of x, right, I will have some value of y or some value of fx, right? In this function, if I substitute, keep on changing the value of x, right, I will get different values of y. Okay, now what if I change, right? So now let's come on this, let's look at this point, right? So at some point, right, at some point, okay, at some point, let's say this is some value x, this is some value x. Corresponding to that, what will I have? I will have some value of fx, right? I will have some value of fx. So this is the value of fx. Okay, please pay attention. Okay, please pay attention. This is very important. So at some value of x, I will have some value of fx. Now what do? I change the value of this x, right, by some small value. Okay, let's suppose x is 100 and I increase the value by 0.1. So what will the value be now? 100 plus 0.1, that is 100.01, right? 100.1, correct? So now basically what is this? What this value will become? X plus delta x. Why x plus delta x? Because I have changed the value, right? So now what is this now? So can I say this length is delta x? Yes or no? This length is delta x, and with respect to this I will have some value of this function. So with respect to this I will have some value, and that value will be how much? That value will be f of x plus delta x. Yes or no? That value will be f of x plus delta x. Clear? But now let's try to understand that what if I make this change very small? Yes or no? If I try to make this change very small, then what will I have? Right? I will have something like this, that for some value of x here, right, this is some value of x which I have here. Okay, I have some value of fx here. I have some value of fx. Now I increase the value by some delta x, right, with respect to this. So what is this? This is x plus delta x. So with respect to that, right, I will have some value here. And what is that value? This value will be f of x plus delta x. So what has happened here? Right, for a small change in my delta x value, the delta y value is not changed that much, correct? Now tell me, if I want to find the area for this strip, okay, what is this? This strip, this particular strip, okay, this particular rectangle, if I want to find the area, right, how can I find the area for this rectangle? So I want to find the area for this rectangle, right? So what is this? This is some rectangle like this, can I say, right? So what is this? This length is, can I say, this is length is delta x. And you try to understand that this strip, okay, now what is the length of this? Okay, breadth I know, but what is the length of this strip? Either you can take f of x or f of x plus delta x, right? But the value change is very small. So what I am taking this length to be f of x. Clear? I am taking this length to be f of x. So now what is the area? The area will be f of x into delta x, f of x into delta x. But now you understand that what if I make this strip more smaller? Okay, see, this is what is happening, that this changes a little bit, x plus delta x is not that small. Okay, clear? When I change, so in this case, what is the value? I took, this is 100, right? Let's say if I took this 100, this was 100.1. Yeah, let's say if this is 100, yes, I am taking this as 100.01. But what if I change this value to 100 to 100.000001? Let's say very small number. Okay, very small change. Just 1 minute. Okay, 100.0001. Okay, 100.000 and 1. So now you have to understand this small change is very small. Okay, this change is very small in x. So similarly, the change in the y coordinate will also be very small, right? So there we will not have this two values, no, f of x and f of x plus delta x. There we will have a single value, that here the value for this corresponding will be somewhere here. Yes or no? Correct? So one value will be f of x and the other value will be f of x plus delta x, f of x plus delta x, sorry, dx, right? And those values will be very, very near to each other. Clear? So in that case, the length of this small triangle, sorry, this rectangle, right? What is this? This is dx, and this will become f of x. Clear? What we are assuming? We are assuming that f of x will be nearly equal to f of x plus dx. Okay? Clear? We are not assuming this. This is like we are proving this, right? Because this is, we know that this will be very small change. Okay? So now once I know this, right, what can I say? The area is equal to f of x into dx. Okay? But what is this? This area is for this small strip only, no? The small strip which I am talking, this area is for that, right? So this area is basically the small area for the strip. For the strip considered. Okay? But now what do I want to do? Right? I want to find the total area of this. Right? So now what if, right? Okay, we are coming here. What if we keep on adding, we add all the small strips, right? What do we get? If I add all the small strips, right, we will get area, I can say total area under the curve, no? So basically what I am trying to say, that if I take this strip, if I take all these small strips, right, and if I keep on adding all the areas, what do I get? I get the total area under the curve. Okay, so this is what next we are going to do, right? So this small area dA, right, I am taking this small area to be equal to dA, right? I am assuming this is d into a. What is a? A is area, dA is the small area, right? And what is that? dA is fx dx. And what is addition, right? What is addition when I have continuous values, right? It is integration. Okay, the other name for addition is integration. Through that I will get the total area. Okay, and now we will use the definite integral concept here, because see, now let's suppose if I want to find the area from this point to this point, then what do I need, right? I will need the limits. Okay, so here I will say that I will start from x initial to x final. Okay, and this will tell me that from where to where I have to find the area. So basically, if I want to write, what can I say? Area under the curve is found using integration. Okay, area under the curve is found using integration, and this is very important part. Okay, so if I say that fx dx, and if I integrate from x equals to a to x equals to b, let's say, so what is this? This is basically area under curve fx from where to where? From x equals to a to x equals to b, x equals to a to x equals to b, right? So this is what it means. So let's draw a curve. Okay, let's draw a simple curve. Let's say this is a simple curve which we have. Okay, this is a simple curve, and let's say this is some value a, this is some value a, and this is some value b, right? So this is the total area. Okay, this is the area which is being calculated here. Okay, so this is the area which is being calculated from here to here. Okay, so this is how we will find the area from this point to this point. Okay, clear? So now let's do one example. Okay, let's try to prove this. Okay, using a simple example, let's try to prove this. So let's say if I have this function, okay, the function is y equals to x. This is my function. Okay, and my question is find area from x equals to 0 to x equals to 1, let's say. Okay, so now first of all, forget integration. Okay, let's forget integration and let's try to solve it using simple maths. Okay, simple graphical way. So if I want to find, right, let's suppose if I want to find the area for y equals to x from x equals to 0 to x equals to 1. So let's first draw the graph. So what is y equals to x, right? Y equals to x is a simple line which passes through the origin, right? Correct? And this is my curve. Okay, so now I will say from where to where I have to find, from x equals to 0 to x equals to 1. So x equals to 0 is here, and x equals to 1, right? X equals to 1 will be somewhere here. Correct? So if x equals to 0 is here and x equals to 1 is here, what is this value? This value will be, so for x equals to 1, y will be equal to 1. So this will be y equal to 1. Correct? So now I can say at this point, okay, y equals to 1. So now what is the area I want to find? I want to find this area, no? I want to find this area. Okay, clear? So now if I want to find this area, what is this area equal to? So I can say this area is basically the area of a triangle. Yes, can I say that this is a triangle, simple triangle? And what is the area of a triangle? The area of a triangle is half into base. And what is the base? The base length is 1 year. And what is the height? The height is also 1 year. So basically I am getting area as 1 by 2. I am getting the area as 1 by 2. Correct? But now what I want to do, I want to prove this, that I can find the same answer using integration. Okay, clear? So please, okay, if you have, okay, please explain again. Okay, so you try to understand using this example, and if you have a doubt, please ask me again. Okay, so I am doing a question here, and I hope you understand this, that how I found the area of this triangle, right? Simple. But let's try to find it using integration. Okay, so if I want to find using integration, right, what is the function? My function f of x is equal to x, right? This is my function. okay, and I want to integrate this, right? So I will integrate this function, okay, from x equals to 0 to x equals to 1. Why I will integrate? Because integration, so what is written, that area under the curve is found using integration, okay, and whatever function I have, I will integrate from x equals to a to x equals to b, because for this function, if I want to find my area under the curve from this limit, this point to this point, right, what I'll do, I'll integrate, I'll simply integrate and put these values in my function. So same thing we are doing here, and this is my x equals to 0 to x equals to a. Just 1 minute. Okay, I have missed this dx part. Dx is equal to integration x dx from 0 to 1. Right? Now let's integrate this. So what is the integration of x square? X. So integration of x is x square by 2. How you know this? Because x power n is equal to x power n plus 1 upon n plus 1, right? Integration of x power n is x power n plus 1 upon 1, n plus 1. So here it was 1, so 1 plus 1 will give me 2 and 1 plus 1 will give me 2. Now finally what do I have to do? I will have to substitute the limits. And what are the limits? The limits are 0 to 1. And how do you substitute the limits? You first substitute the upper limit. So what is the upper limit? 1. So this will become 1 square by 2. Then you substitute the lower limit. What is the lower limit? 0, right? So this will become 0 square by 2. And you find the difference of these two values. Correct? So what do I get? I get 1 by 2 minus 0. So finally what do I get? I again get 1 by 2. Right? So these are the two ways through which I can find the area under the curve. Right? This is by simple graphical method. No, I draw the graph of this curve, and this is by simple integration. Correct? Yes or no? So now I am able to find the area, but now you try to understand, right? This graph is easy to draw. This graph is easy to draw. But what if I give you some difficult graph? What if I give you some difficult function? Let's say if I give you, right, this is a homework question, you please try to solve this, okay? This is a similar question, but what if I give you some function like this? Let's say my function is, right, this. My function is y equals to cos x. Let's say this is my function, right? And this, what does y equals to cos x looks like? This is y equals to cos x. This looks like this, correct? Where this is what? This is 0, right? This is pi by 2. This is what? Pi, and this is 2 pi. So now how to find the value for this curve, right? This is not a straight curve, or this is not forming a triangle, circle, right? So now in this case what we'll do? We'll again do integration. Okay, please look again. I will do one more question. It will be helpful for you if you are not able to understand. So what I'll do, I'll integrate this function, right? So what is the integration of cos x dx? I'll integrate this function, right? And from where to where I'll integrate? I'll integrate from x equals to 0 to x equals to 2 pi. From x equals to 0 to x equals to 2 pi, because what do I want to do? I want to find the area bounded by the curve y equals to cos x between x equals to 0 and x equals to 2 pi, right? So what is this? X equals to 0, from x, this is the total area which I want to find. Yes or no? This is the total area which I want to find. So let's try to solve this. So now what is this? So integration of cos x. What is integration of cos x? Integration of cos x is simple sin x, right? You should know what is the integration of simple values, right? What is the integration of sine? What is integration of cos? What is integration of tan, right? These all values you should know. So integration of sine is, of cos is sin x, right? Okay, now I'll substitute the values. So let's substitute the values. What are the values? X equals to 0 to x equals to 2 pi. Yes or no? So I have done the integration and I'll substitute the values. So what will I get? I will get sine of 2 pi, right? This is my upper limit which I have substituted, minus sine of my lower limit. Sine of my lower limit. Clear? This is what I have, okay? Sine of upper limit minus sine of lower limit. Clear? Now, what to do from here? Now, from here, right, I will substitute the values. So, what is value of sine 2 pi? Right? If I want to find the value of sine 2 pi, what is sine 2 pi? Okay, so first of all, what is sine 2 pi? Sine 2 pi, it is sine 360. Okay, so let's, for those who don't know the value of sine, right, the sine graph is something like this. This is 0, this is pi by 2, this is pi, this will be 3 pi by 2, right, and this will be 2 pi. Correct? So I know that what is the value of sine 2 pi? Sine 2 pi is 0. Okay, so sine 2 pi is 0. Just 1 minute, okay? Have I made some mistake? Just 1 minute, okay? Okay, clear? So now, right, so what do I have from sine 2 pi? So what is the value of sine 2 pi? The value of sine 2 pi is 0 minus. What is the value of cos sine 0? Sine 0 is also equal to 0. So what do I get? Finally, I get the answer as 0. Okay, so this is how, right, this is how, just I have made one mistake. Okay, what is the mistake here? That this will be equal to 3 pi by 2. Okay, this will not be equal to, this will be equal to 3 pi by 2, and this will be equal to 2 pi. So basically we are finding this total area. This is the total area which we are trying to find. Clear? Okay, so now this is, we are getting 0 minus 0, correct? So now what do you get? See, this is the positive area which I have, and this is the negative area. So this is why I am getting 0. You should be interested that why we are getting answer as 0. Okay, you are getting 0 because what is happening, that this area, if you try to understand that this and this will be similar to this. Okay, if you understand that this is a bowl kind of shape, no, this is a bowl, a semicircle, and this is a quarter circle and this is a quarter circle. Actually they are not a circle, okay, but for assumption that if this is a semicircle, this is a quarter circle and this is a quarter circle, so this will have positive value. Basically what will happen, that this will have positive area, this will have positive area, and this will have negative area. So this positive and this negative will cancel, and we will have a 0 area. Clear? Let's do. Okay, so I'll give you one more question. Okay, I'll give you one more question. Right, say the question is that y equals to x square plus 2. Let's say this is my function. Okay, and I tell you that find area under curve from for x equals to -1 to x equals to 1. Let's say if this is the question which I have, correct? So now here we don't have to draw the graph. Okay, I know that the graph will look something like this, correct? But I don't care about the graph. Okay, because what I want to do, let's suppose this is the graph, right? From x equals to, let's say -1 will be somewhere here. Okay, -1 to what? 1, right? I am basically interested in this area, correct? But if I use this graphical method, it will be very difficult. What we are trying to do, we are trying to find the area using integration, right? So let's integrate again. So integration x square plus 2 dx from x equals to -1 to x equals to 1. What will this give me? This will directly give me this area in which I am interested. Okay, clear? So let's try to find this, right? So what do I get from here? From this, right? What is x integration of x square? This will become x cubed by 3, and this will be equal to 2x. And finally, what do I have to do? I will have to substitute my limits. And what are the limits? Limits are from -1 to 1. So let's substitute the upper limit. So what is the upper limit? I will get 1 cube by 3, correct, plus 2 into 1, right? This is my for upper limit, minus for lower limit. What do I get? Minus 1 cube by 3, right, plus 2 into minus 1, correct? Now let's try to solve this. So what do I get? This will become 1 by 3 plus 2 minus, right, this will become again minus 1 by 3 minus 2. So this will become 1 by 3 plus 1 by 3, this will give me 2 by 3, 2 by 3 plus 4. So what do I get finally? 3 4s are 12, 13, 14, 14 by 3, right? So this is my final answer, okay? So this area is equal to how much? 14 by 3, correct? So without the knowledge of the graph, how does it look like, right? I will be able to find the area under the curve, okay? So this is a application of integration, and we will be using this, okay, later on to calculate the distance, okay, distance moved by the body or the total velocity of the body, right? There are many things related to this, right? This is an application, so please understand this now, okay, and later on in physics this will be very helpful for you, okay? So with this, okay, I have finished basically the vector part, okay? We are not done with the class, we are done with the integration part. So this is the last topic that I am going to start now, and that is vectors, okay? So we are going to start with vectors now, correct? So let's start, okay, without wasting time. So this, now let me tell you first of all, okay, this vector section is very important, okay, because in each and every chapter, okay, they will say that, okay, this vector is acting in this direction, okay, force, this force of vector 2 Newton, okay, is acting along the x direction, or acceleration is also a vector. So physics is full of vectors, and if you don't understand this chapter very nicely, okay, what will happen? Eventually you will hate physics, because you will not be able to solve questions, okay? So as I told you that this series which we are doing right now, okay, this transition course, right, is basically preparing you for the upcoming classes which are going to start, okay? So please pay attention, okay, and whatever doubt you have, you please try to clear it, okay? So how you can clear your doubts? By scanning this. You please scan this QR code, and whatever doubt you have, you can send it here. Similarly, please join our Telegram channel, okay, and please understand, okay, vectors is very important chapter for you, okay? You cannot afford to miss it, okay, or leave it that, okay, I will not do this chapter, I will do something else. If you don't do this chapter, physics will become very difficult for you, okay? So please pay attention. So let's start. So now vectors, okay, so there are two types of physical quantities which we have in physics. What are the two types of physical quantities? One is a scalar and one is a vector, right? So what are scalars and vectors? Okay, so let's understand. Physical quantities having magnitude only, example time, distance and speed. So when I say physical quantities which have only magnitude, right? So like time, no? When I say what is the time right now? So let's say the time is 5:40 right now, right? So when I say 5:40, right, I don't specify anything, right? I only have magnitude, right? I don't say that it is 5:40 in this direction or 5:40 in this direction. Yes or no? Let's say if Virat Kohli score runs, right? Virat Kohli score runs, and let's say he scored 50 runs. Let's say he scored 50 runs, correct? So what I'll say, he scored 50 runs. Only this is a number only, right? This is just a number. This is just a number, correct? I don't say that Virat Kohli scored 50 runs in this direction or 50 runs in that direction. Yes or no? Okay, so this is just a number, right? And that is what a scalar quantity is. So time is a scalar quantity. Distance, right? So let's say distance is, I'll say that this place is 10 kilometers away. Yes or no? So 10 kilometers is the distance. Speed, okay, I am running at a speed of 10 kilometers per hour, or basically when you are going on a bike, right, you see the speedometer, no, It tells you that what is the speed of that particular vehicle at that time, right? So that these are the scalar quantities. Okay, but now you know what are scalars, but what is vector now? So this is something new for you. Okay, what is vector? Physical quantities which have magnitude, right? Magnitude means some number associated with it, some number associated with it. Correct? Now second is what? Second is direction. What is second? Direction is very important. Okay, it tells you that in which direction. So let's suppose if I tell that, okay, please apply a force. Okay, please apply a force on this. Let's suppose this is the remote which I have, and I tell you please apply a force. Now you will be confused that, okay, in which direction to apply force, right? So I will tell you that please apply a force towards right, please apply a force towards left, right? So for some quantities for which I have to specify direction as well. With number, I also have to specify direction. That is known as a vector quantity. Okay, clear? So now let's, for an example, let's understand. Okay, so that let's say this is my remote, right? Now to hold this, okay, simply to hold this, right? If I keep this on a table, let's say this hand is a table, and if I keep this remote on this table, can you tell me in which direction is the force is being applied by my hand, right? I'll repeat my question. In which direction is my hand applying force on this remote? So what is the answer? The answer is in the upper direction, because see what is happening, that remote is trying to fall down, but due to my hand, what is happening? This remote is not able to fall down. So this remote wants to go down, but my hand is supporting it and is applying a force in the upper direction. Yes or no? So here we have direction, and how much force is being applied? So that is basically the number. It is equal to the weight of this, no? So the weight which is acting downwards is basically the force that is being applied by my hand upwards. Yes or no? So this is basically what vector quantity is. Okay, now let's suppose I'll give you one more example. Okay, now let's suppose if I am standing at this point, let's suppose I am standing on this right hand side of the board. Okay, and if you tell me that, if I tell you please go to the left hand side of this board, right? So basically I am telling you, no, that I am telling you that what is the direction. This is the direction, right? Left hand side. So this is the left hand side. So have I went to the left hand side of the board? Yes, because I have also specified a number. What is the number? The number is the distance from this board to this point, right? From this point to this point. If I am standing here and if I say please go to the left, right? If you only tell me please go to the left, I can come here, right? Or I can come here, right? Or I can finally go there also. Yes or no? But when you tell me that please go to the left hand side of the board, right? Basically you are telling me that please go specifically here. Okay, so here you have specified direction, yes, as well as magnitude. And what is the magnitude? The magnitude is the length of this board. Clear? So this is what scalar quantity and vector quantity is. Okay, so what are some vector quantities, right? Acceleration is a vector, velocity is vector. Okay, we will learn that what is the difference between speed and velocity, right? What is the difference between distance and displacement, right? What is time? Time is a scalar quantity, right? Because when you talk about time, we don't have any specific direction. Okay, what is force? Force is a scalar quantity, vector quantity. Now work. What do you think work is? Okay, work is a scalar quantity, because when I say that I am doing work, let's say that I studied for 8 hours or I did this much amount of work, right? I don't tell that, okay, in this direction I did this much amount of work. Okay, so work is a scalar quantity. Okay, so as we go along, this will be, you will understand. Okay, you will understand that what is work and what is scalar and what is vector. Okay, so now this last is follow vector algebra. What is vector algebra? We'll understand this. Okay, for now it's okay. Let's start. So now representation of a vector. So how do you represent a vector, right? How do you represent a vector? So when I was standing here, okay, and if I want to tell someone that okay, please go that end of the board, right? So what I'll do, I will point, no, without speaking. If I want to say something, I will point in that direction. So basically what I am trying to say, right, please go there. Okay, so direction is given, but how much? So let's understand that geometric representation of a vector. So magnitude is mod A or A. What is the magnitude? Magnitude is mod A. So when I specify this modulus function, what is it trying to say? It is basically specifying the number. Specify the number of the quantity. Okay, number, I can say value of the quantity. Now length of the arrow is directly proportional to the magnitude of this vector, right? So let's say that if this vector, okay, so what is this? This is basically a vector and this is pointing in this direction. So basically if I don't make this arrow, right, this will be a normal line, but when I draw an arrow, right, it is pointing in that direction. So one condition is fulfilled, right, direction is fulfilled. Let's say if this is, let's say 1 meter, right, what will be 2 meters? So can I say 2 meters will be a vector of double the length? Why double the length? Because if this is 1 meter, this will be, because say when I double this, when I take this vector and I bring it again here, yes, this will be twice the length, and direction is in this direction. Okay, so this is how you represent a vector. So a vector is represented by an arrow, right? This arrow represents the direction, and this length, the length of this is basically specifying the magnitude of this vector. Okay, the length of this is specifically specifying the vector. And how do you represent a vector? This is how you represent a vector, vector A. That A is a vector or a scalar. So if I only write A, right, if I only write A, that A is basically a scalar quantity. But if I add an arrow at the top, an arrow like this, that will tell me that that is a vector quantity. Okay, so now let's do one thing. Okay, we don't have so much time now, so we will continue with the class tomorrow. Okay, and we will continue with vectors. Clear? So before we start with vectors, what I want you to do, okay, please go through this playlist. Okay, you will get this playlist in the live section. Okay, it is for both JEE and NEET students. Okay, whatever we have done in this transition course, okay, the name of this playlist is transition course. So whatever we have done in this transition course is basically something that will help you to do well in your 11th, correct? And when I say it will help you to do well, right, I mean it, because you will, if you finish this course and you try to apply the concepts, right, you will see the difference within the first month only. Okay, so please go watch the playlist, and whatever doubt you have, okay, please do one thing, just scan this Google form. Okay, in that Google form, right, whatever doubt you have, you please write it and send it to us, right? We will try to help you. Our team will call you, and also please join this Telegram channel. Okay, on this Telegram channel there are many activities that are going on, right? We share planners, okay, timetables, okay, daily questions are there on this Telegram. Okay, there are many things that are going on this Telegram. Please don't miss it. Please join this. Okay, and okay, so thank you. We'll meet again tomorrow, same time at 5 o'clock. Okay, I hope you enjoyed this session. Please give a thumbs up. Okay, subscribe to the channel. Thank you everyone. Have a nice day.